Hi guys, this is Mrs. Young, and today we are continuing our review of the functions unit. So I'd like you to go ahead and open up your packet to page 40. This is almost the very last page there in your packet, so page 40. And we're going to do a few review problems together right now. So here on page 40, again, if you don't have your packet, you can write this on your own paper, or the packet's posted electronically in Google Classroom. So it says fence company A charges $2,500 for building materials and $175 per foot for the length of the fence. This is represented by the equation 175x plus 2,500. So again, this is company A, and they actually gave us the equation, which is kind of nice. Again, we know that the 2,500 is our y-intercept. That's your starting point. That's the upfront fee. And then the 175 is your slope or rate because it's per foot. So every foot of fence, they're going to charge them $175. So that's your rate or rate of change or slope. Now it says fence company B charges based on the length of the fence also. So we have a different company here, B. The table below represents the input and outputs for fence company B. So instead of a equation, we actually have a table of values for company B. It says calculate the rate per foot of fencing for company B. Again, whenever they talk about slope, rate, we know that they are talking about slope, rate of change, slope. In our table, we know the first column is your X values and the second column is your Y values. So what I'd like you to do right now is go ahead and label these X1, Y1, X2, Y2. Plug the numbers into your slope formula and calculate the slope for this. So go ahead and pause the video, calculate your slope, and come back and check your value with me. So go ahead and pause it. So checking your slope value, again, I plug the numbers into the slope formula. You should know the slope formula. If not, make sure you have it written down somewhere. As I plug in the numbers, I came up with 1125 over 5, which in my calculator gave me $225. So that's the cost per foot of fence. That's their rate or rate of change or slope. The second question here says, which company charges a higher rate? So I know in company A that the slope is my rate. So that has a rate or slope of 175. And then I know in company B, we just calculated our rate here to be 225. Well, clearly the higher rate is company B. So we're going to say which company charges the higher rate. We can say company B charges a higher rate. How do you know? I'm going to say because 225 is greater than 175, right? The cost per foot is higher at company B. Again, during these videos, if you ever need to pause or rewind or rewatch them, you can. Now, part 3 or question 3, it says, is company B linear in its pricing model? When we picked those first 2 points and plugged them into the slope formula, we assumed that it was the same throughout the entire table, but we honestly did not know that. So if it's linear, we know that it's going to be going up at a constant rate. So we have to check and see, is it going up at a constant rate? So if we look at our first 2 points, these are the ones we already looked at, from 5 to 10, that goes up by 5. And then we know that our y values went up by 1125. Remember, the slope or rate of change is the change in y over change in x. So 1125 over 5, we know that we got 225. That was our slope formula that we already did. But if I look at the middle 2 set of numbers, if I go from 10 to 20, how much does that go up? From 10 to 20, you're going up by 10. And then if you look at your y values, if you go from 2250 to 4500, how much is that going up by? That's where you might want your calculator. So 4500 minus 2250, on my calculator, I get 2250. So there, the y values are going up by 2250. Again, your rate or rate of change or slope is your change in y over your change in x. And then if I divide this on my calculator, I get 225. So far it is looking linear. It does look like it's going up at a constant rate, but we need to check the last point down there. If I go from 20 to 35, that's going up by 15. If I go from 4,500 to 7,875, again, there's where I probably need my calculator. 7,875 minus 4,500, I'm going to come up with 3,375. So again, looking at your change in y over your change in x, 3,375 divided by 15 on your calculator, you should come up with 225. So we can see that it keeps going up at a constant rate. So is it linear in its pricing model? We're going to say yes, company B is linear. Because it says to justify my answer, I'll say because the numbers are going up at a constant rate. Of 225 per foot of fencing. Every time you buy another foot of fencing, it's going to keep going up $225. Another way that you can see that it's linear is if you took all the numbers from the table and plotted them on a graph. But these numbers are so huge, I wouldn't want to have to plot them on a graph. Plus, we don't have graph paper here in our packet. So you could see that if you graphed it, that it would be a straight line, but you can also see it if your values are going up at a constant rate. I am here on page 40. I am going to skip number 4 and number 5. So we're skipping 4 and 5. And let's go ahead and turn over to page 41. So on page 41, different problem. It says here that Anne has a plan for distributing prize money for a trivia contest. For qualifying to participate, the contestant receives $400, and then for each correct response, they'll get $150. Is this linear or nonlinear? Again, this is Anne's plan for distributing money. And maybe let's make a table of values. So we have the number of questions you answer correctly, and then how much money you're going to win, your prize money. Now this one says, in Anne's plan, it says for qualifying, you get $400. So even if you don't get any questions right, let's say you get 0 questions right, 0 questions right, you're still going to get $400 because you qualified for this trivia contest. And then for each correct response, you get $150. So if I get one question right, I get $150 plus the $400 I got for qualifying. So this is going to go up to $550. If I get 2 questions correct, again, I'm going to earn another $150. So this is going to go up to $650, $700. If I get 3 questions correct, this is going to go up to $850. If I get 4 questions correct, $850, $950, $1,000. If I get 5 questions correct, this is going to be $1,150. If I get 6 questions correct, let's see, $150, $250, $300, $1,300. There's a reason I went up that far in my table. You'll see in a minute, but you can see every time you get another question correct, the amount of money you win, the prize money, is going to go up by $150. So is it linear? Yeah, because every time the X value goes up by 1, the Y values keep going up by $150. So we can say it's linear. How do you know? We're going to say because the amount of money is going up at a constant rate, of $150 per question. So every time you get another question correct, you keep winning or earning another $150. So we can see that constant rate in our table. Now we have Amy, a different person, and she has a different plan for distributing prize money for the trivia contest. So it says here that the contestant will receive $4 for the first correct response. For the second correct response, they get a total of $16. For the third correct response, they get $64, and so on. So we want to make a table of values that represent Amy's plan. So again, I'm going to make another table of values. The first column will be the number of questions that we get correct. And then the second column will be how much money we're going to win or earn. Now with this one, you get $4 for the first correct response, but they don't mention any prize or money up front. So if you get 0 questions right, you're not going to win any money. One question right, you're going to get $4. 2 questions right, again, your total is going to be $16. 3 questions correct, $64. And then it says, and so on. We have to figure out a pattern. What is happening here in our table of values? I can see that I'm going from 4 to 16 and then 16 to 64. So they're not adding something. It's getting larger. It's definitely not linear, right? It's not going up by the same amount each time. This goes up by 4. This goes up by 12. This goes up by 40 or 50 something, right? So it's not going up linear. But what is it doing? Well, if I know when I go from 4 to 16, I'm looking for like a multiplier here. I can see that 4 times 4 is 16. And then if I took 16 times 4, check on your calculator, but 16 times 4, 40, that's 64. So they keep multiplying by 4. So if we got 4 questions correct, so if I took 64 and multiplied that by 4, check on your calculator, 64 times 4, I think that's going to give me 256. Then if we take 256 and multiply that by 4, again, they keep multiplying by 4. There's like a multiplier here. So 5 questions correct. 256 times 4, that's over $1,000. That's 1,024. Again, using your calculator to help you out there. And then finally, if I take 1,024 and multiply that by 4, I'm going to get 4,096. And again, it'll keep going at that same pattern. We're multiplying by 4. So is her model linear or nonlinear? We're going to say nonlinear. How do you know? We're going to say because the amount of money that you're winning is not going up at a constant rate. And if anything, you could even say that it's multiplied by 4, right? There's a multiplier here. We're just not adding the same amount each time. If you get 6 questions correct, whose plan, Anne or Amy's, earns you more money? So this is why I made my tables go up to 6. So I can see 6 correct with Anne's plan, I get $1,300. 6 correct with Amy's plan, I get over $4,000. So clearly Amy's plan is going to pay me more money. So I'll say Amy's plan pays more for 6 questions. Because I guess I should explain this. I'll say because 4,096 is clearly more than $1,300. So we're clearly making more money with Amy's plan with 6 questions. How much more money do you earn with this plan you chose? Again, I'm assuming they mean with 6 questions. Like how much more do I earn if I answer 6 correct? So if I took 4,096 minus 1,300, let's see, 40 minus 13, 30, 27.96. So how much more do I earn? We're going to say that you earn 2,796 more with Amy's plan. And again, we're assuming that they're saying with 6 questions. So in both of these 2 pages, pages 40 and 41, we kind of reviewed some concepts of comparing rates between 2 different plans. And we also talked a little bit about slope and looking for that constant rate or rate of change in a table or an equation. So your homework tonight is going to be 2 problems just like this. I know that they are not in your packet, but I will post them in Google Classroom. So you can either print them out if you have access to a printer and write on your printout and take a pic and submit that. Or if you don't have a printer, you can write it out yourself on paper and take a pic and submit that. Or your third option is to use the Kami app where you can write on it electronically. So one of those three ways to submit. And I will post all of this in Google Classroom. So thanks for reviewing with me again today, and good luck on your homework. Stay safe and stay healthy.